Hello again. This is a lesson that I've always liked because I've always found it to be very practical, and it allows me to use real-life examples. Not that I don't use real-life examples in my other lessons, but clearly something that tends to be a little bit more applicable than some of the other math that you do. And it's related along the same thing because it's a ratio, so we're going to deal with this. And it's called percent of change. And there's a very simple formula for percent of change. And it's the price difference of a product that you're comparing, the old price and the new price, divided by whatever the original price was. And this can be used in both ways. It could be a price decrease or it could be a price increase. In fact, businesses use this all the time. If you're shopping at a trendy store, they tend to mark up their merchandise more. Me, on the other hand, I get my suspenders wherever they're cheapest, so I'm pretty frugal about that. I don't really like going to, hip places because it's, when I think of hip, I think of, this area of my body. I don't think of, a status cool. Oh my gosh, I'm so funny sometimes. Anyways, so I'm not really too big into fashion, but I dress in what I like and it kind of works out for me. And you can also use it in stores that are making a clearance, a discount. So it works in both ways. And I've got two examples up here, and I'll attach a story to them because I feel like there's a little bit more personality when I do that. So I went shopping. Well, I didn't go shopping. I was accompanying somebody that was going shopping. I just kind of got dragged along. And, when I go shopping, it doesn't take me that long to look for what I want, yeah, I got my shoes, I got my shirt, I got my pants on clearance, I get my stuff when everything's cheap, and that's pretty much it. I kind of like to avoid the crowds too, I don't really like playing shoulder tag with everybody that's shopping, but that's something altogether. So I'm shopping with this person because she wants an opinion on something, and she's looking at something. Let's say they're, I don't know, some kind of, we'll go with sweater that had an old price of $80. And the clearance price was $30. And she wanted to know what the percent difference was. And, since I'm a math teacher, I'm supposed to be able to do these calculations in my head, which I was able to do in my head, but, maybe that's a little bit of a stereotype that all math people can just figure out things like that. But, sometimes you can. So the old price is $80. And the clearance price is $30. I want to find out, was there a difference, a percent of decrease or a percent of increase? Well, it's pretty obvious that it's a percent of decrease because if this was the original price and it was marked down, obviously it decreased in price. But we're going to find out what the percent of change was using this formula, the price difference divided by the original amount. Now, what you do is you take the difference of the two prices and you take the bigger of the two. You don't take 30 minus 80, you take 80 minus 30. Whichever one's the bigger of the two you take. You're not going to come up with a negative 50, you're going to come up with a positive 50. So in this case, the price difference between the old price and the clearance is $50. So I'm going to write 80 minus 30 over the original amount. Now, which one was the original amount? The clearance price or the old price? Well, clearly, whichever one was the first price is the original amount. So it's $80. Which comes out to 50 over 80, because 80 subtracted 30 is 50. And now I have to figure out what that is. The reason why I know what 5/8 is or 8/5 is because I run a lot. So I know the conversion ratio between kilometers to miles and miles to kilometers. But I probably would have figured it out anyways. I know that 5 divided by 8 is 0.625. Therefore, 50 divided by 80 is the same thing as 0.625. So it comes out to 0.625. But that's not represented as a percent. In order to represent a decimal as a percent when you're dividing two numbers or when you're dividing a ratio, you multiply it by 100. So you take your decimal, 0.625, and you divide it by 100. Excuse me, not divide it by 100. You multiply it by 100. Just in case I didn't say that once, I'll say it twice. You change a decimal to a percent by multiplying by 100. And 0.625 times 100, all you really got to do is just move the decimal place over to the right twice. But you can do it in your head, you can do it on a calculator, you can do it by hand. Either way is fine. And it comes out to 62.5%. And that's what I said, you know, the clearance price was 62.5%. The person said, you're pretty useful. I'm like, well, you know, I like to consider myself more than useful just in mathematics, but, you know, I'll take the compliment where I can get it. Is that a true story? I don't know, but it's definitely more entertaining than just kind of doing the problem. I'm getting older every single day, and I can feel myself getting older. But, you know, I'm going to trade those beautiful good looks and, you know, relative sprite attitude for hopefully wisdom. I'm certainly not going to trade it for fashion or trendiness. But I use this example with my students because I guess high school students in general need to look hip, they need to look trendy. But I say, just work on your personality. You don't have to worry about anything else, just work on your personality, be chill, be nice to everybody. And it kind of works out better that way. Well, anyways, the example I use is, let's say you're shopping at a store, and then I ask my students, you know, what's a cool place to shop? Because I don't know what's a cool place to shop. I just shop where I shop. And I've had, especially female students who will just say out loud, Forever 21, Forever 21, or whatever is going to be popular in 6 months or a year. So I catalog Forever 21 because that's what I'm going to use. So Forever 21's got these brand new hip jeans out that cost them $8 to make. And just like any trendy place, they're going to mark it up so outrageously, but since it's in high demand, people are going to buy it. You know, I'd forever like to be 21 too, but not at those types of prices. So with that said, here's what we have to do. We take the difference in price and we divide it by the old price. So the difference is 60, subtract by 8. You can do 8 minus 60, but you don't want a negative number. So we go 60 over 8, and the original price is 8, which comes out to 52 over 8, which comes out to, let's see, that's 52 over 8 is the same thing as 26 over 4, 13 over 2, 6.5, 6.5. That is not a percent. The percent markup in this case, and it was marked up, is not 6.5%, because we still have to take this decimal and multiply it by 100. You take 6.5 times 100, and you get 650%. The markup is 650%. Like I said, I'd forever like to be 21. I guess I'd forever have to be 21 given that. Actually, I've never shopped there, so I really don't know. So please don't talk to me about slander or anything else. This is just a joke. So if you take that offensively, I apologize. It's just humor in that case. But in either case, it's just an example that you use. So hopefully there's nobody out there who's going to take it too seriously and get very angry about it. With that said, that's an example of markdown and markup. This one is a little outrageous, and I'm pretty sure this is not the case. It's probably not typical. This one could be typical. I've never seen a markup of 650%, but then again, I don't shop at every single store. With that said, have a great day. Goodbye.